Let us continue alkali metals. In the alkali metals, you will go for manufacture of sodium carbonate. In the manufacture of sodium carbonate, we will take Solvay process. Solvay process, otherwise ammonia soda process. Solvay process, otherwise ammonia soda process. Solvay process or ammonia soda process we will discuss. In this, first we will take one tower. In this tower, we will take brine solution. So we are taking brine solution. Then we are passing ammonia and a little carbon dioxide. Ammonia and a little carbon dioxide we are passing. So what will happen here? In this tower, what will happen? That we will discuss. So we have taken brine solution. That brine solution contains calcium ions, magnesium ions, sodium ions, and anions. Anions also present, even cations also present. We have passed ammonia and a little carbon dioxide. Due to little carbon dioxide, we are getting ammonium carbonate. This ammonium carbonate converts this calcium ion into calcium carbonate, which is precipitate. Magnesium ion is converting into magnesium carbonate. Magnesium ion is converted into magnesium carbonate, which is precipitated. So in this first tower, we have passed ammonia gas and little carbon dioxide. Ammonia and carbon dioxide becomes ammonium carbonate. Ammonium carbonate converts calcium ion into calcium carbonate precipitate, magnesium ion into magnesium carbonate precipitate. Then anions are not involved in this one. Anions are not precipitated. Alkali metal cations are not precipitated. Other than alkali metal ions means they are precipitated as carbonates. So in the brine solution, alkali metal ions are not precipitated in this tower. Other than alkali metal cations are precipitated as carbonates. Anions are not converted. So to this tower, to the brine solution, we are passing ammonia gas, and we are saturating the brine solution with ammonia. Therefore, this first tower is called ammonia saturation tower. Ammonia saturation tower, we can say. So after the chemical process, the solution is filtered. Here. On filtration, we are getting one is called residue, another one is called filtrate. We are getting one residue, another one is called filtrate. We are getting this residue means the precipitated one is called residue, insoluble one is called residue. Which are insoluble in the sense calcium carbonate, magnesium carbonate, the carbonates are insoluble. The filtrate contains alkali metal ions, sodium ions present, that excess ammonium carbonate, that means excess ammonia and the remaining carbon dioxide present. This excess ammonia and if carbon dioxide remaining means they are in the form of ammonium carbonate. That ammonium carbonate excess is there in the filtrate. So this first tower is called ammonia saturation tower. In this tower we have precipitated the metal cations present in the brine solution other than alkali metal ions. Okay, next we are going for second tower. This is a second tower. Now this filtrate is taken into this tower. This filtrate, this first stage, first tower filtrate is taken into the second tower. Then carbon dioxide gas is passed into this tower. Carbon dioxide gas is passed into this second tower. The carbon dioxide gas is passed from bottom of the tower. Then carbon dioxide can move up like this. The filtrate of first tower will be poured into second tower from top. Therefore, filtrate will come down like this. Sorry. Now, in second tower, what reaction takes place? That we will see. In second tower, we are passing carbon dioxide gas. First stage filtrate, first tower filtrate we are taking to second tower that contains water molecules, and first tower filtrate contains ammonia. Here in the second tower we are passing carbon dioxide, therefore carbon dioxide is excess, so that we are getting ammonium bicarbonate, not ammonium carbonate. We are getting ammonium bicarbonate we are getting. So first tower filtrate contains saturated solution of ammonia. First tower filtrate is saturated solution of ammonia. In the second tower we are passing carbon dioxide, so ammonia and carbon dioxide becomes ammonium bicarbonate in the second tower. But in first tower ammonium carbonate we got, because carbon dioxide is little, ammonia is excess. In second tower carbon dioxide is excess, therefore we are getting ammonium bicarbonate. Then first tower filtrate contains alkali metal ions, sodium ions. These sodium ions combining with ammonium bicarbonate and becomes what in the sense sodium bicarbonate. Sodium bicarbonate, ammonium ion goes to solution. Sodium bicarbonate we got. So in this tower we are passing carbon dioxide, therefore it is called a carbonation tower. We are calling this is as a carbonation tower. So we have gone for a carbonation tower. In the carbonation tower we have prepared what in the sense sodium bicarbonate we have prepared. We have got sodium bicarbonate we have got. Okay. So we got a sodium bicarbonate in the second tower. Then we will go for filtration of second tower. This we will go take for filtration. This on filtration we are getting residue and filtrate. What is the residue we are getting means sodium bicarbonate as the residue we are getting. Sodium bicarbonate residue we are getting. Then filtrate contains what? Filtrate contains ammonium ions, excess bicarbonate ions, ammonium ions and excess bicarbonate ions are present in the filtrate. Now this process is called Solvay process. In this process we are manufacturing sodium carbonate, but we got here sodium bicarbonate we got. Now we have to convert this sodium bicarbonate into sodium carbonate, for which we have to take this for ignition. This sodium bicarbonate we have to convert into sodium carbonate now. Okay, how to convert sodium bicarbonate into sodium carbonate, that we'll see. Sodium bicarbonate we have to convert into sodium carbonate. Any bicarbonate on heating decomposes to give carbonate. Therefore sodium bicarbonate on heating gives carbonate, then carbon dioxide gas is released and water. So this on ignition we are getting sodium carbonate. Okay, so the sodium bicarbonate is ignited. This is ignited. This on ignition, we are getting what in the sense? Sodium carbonate we are getting. Okay. Now, we manufactured sodium carbonate here. So, the goal of this method is preparing sodium carbonate. That's what we have prepared. Okay. Rest of the things in this method we'll see. We want to pass in this to this carbonation tower. We are passing carbon dioxide. That carbon dioxide gas, how we are getting, that we'll see. For that case, here one furnace is placed. Here we have placed a furnace. Here furnace is placed here. In this furnace, what we are taking means limestone we are taking. We are pouring limestone here. After pouring limestone, we have to close this. So we are keeping like this arrangement. If we pull this one, this part will close this hole. So here we are taking what in the sense calcium carbonate. Then here we are keeping one vessel. In this vessel, what is placed in the sense water is placed. Water is placed in this vessel. Okay. So in this number 4, what we are taking? In the number 4, what we are taking means calcium carbonate, limestone. It is heated. It decomposes to give what means calcium oxide and carbon dioxide. This carbon dioxide, so calcium carbonate on heating gives calcium oxide and carbon dioxide. This is called a lime kiln. This is called lime kiln. Furnace. Kiln means furnace. So here we are taking calcium carbonate. The calcium carbonate decomposes to give carbon dioxide, which is moving up. That carbon dioxide is taken and say sent into second tower. Calcium oxide is solid. That calcium oxide is falling into this one, falling into here, falling into this place. This calcium oxide combining with water to give what in the sense calcium hydroxide. Calcium hydroxide. So here what is produced means calcium hydroxide is produced. Here this limestone. Here limestone we have taken that decomposes to give calcium oxide, which comes down, which falls down into water. That calcium oxide combines with water and becomes what means calcium hydroxide. Next, here one tower is taken. Here one tower is taken. Now, what we are doing in the sense, here filtrate contains ammonium ions and bicarbonate ions, that is taken into this tower. That is taken into this tower. The here filtrate contains ammonium ions and bicarbonate ions, and if anions any is present, anions in the sense this brine solution contains anions, chlorides, sulfates like this. Those anions also will be present. They are complete together. This filtrate complete together is taken into this place. Here, suppose here Cl minus anion is there, means that Cl minus anion comes to this filtrate and comes to this filtrate. No change for this anion. Similarly, in this brine solution, sulfate is there, means that sulfate comes to this filtrate, that comes to this filtrate, that is taken into this place like this. So then here in this one tube is inserted like this. One spiral tube is inserted like this. Through this spiral tube, what is sent in the sense, steam is sent. Steam is sent into this steam. Then the produced calcium hydroxide also taken into this tower. So to this tower, what and all taken in the sense, this filtrate is taken into this tower. This calcium hydroxide is taken into this tower. Then steam is passed into this tower. Steam is not passed. A tube is placed in the tower. Inside the tube, steam is passed. Okay, like this we are doing. So what is happening here? What will happen? That we'll see. In this tower, what will happen? So in this tower, what is happening means, Ammonium salts we are taking into this tower. We are adding strong base calcium hydroxide, that is steam is passed, therefore solution is heated. Ammonium salts on heating with the strong base gives ammonia gas. Then we have taken bicarbonate. We have taken bicarbonate into this tower. Bicarbonate we have taken into this tower. Bicarbonate decomposes to give carbon dioxide and water. Bicarbonate decomposes to give carbon dioxide and water. So ammonium salts we have taken into this tower that is heated with a strong base, so we are getting ammonia gas. Bicarbonate decomposes to give carbon dioxide and water. This calcium ion goes to solution. This calcium ion goes to solution. So in this tower, what we have got, we will see. First, in this tower, we have passed ammonia. That ammonia, we have passed ammonia, that ammonia came to this filtrate. This filtrate we have passed into second tower, that ammonia comes to this filtrate. That ammonium ions we have taken into this tower, that ammonium ion is converted into ammonia that is coming up, that ammonia is passed into this place. Okay, so you see that we are passing ammonia into first tower, that ammonia comes to the filtrate as ammonium ion, otherwise ammonia, like this. It is taken into second tower, that ammonia comes to filtrate as ammonium ion. This ammonium ion is taken into this tower, that becomes ammonia that is passed into this. That means what this tower does, this tower regenerates the ammonia. Therefore this tower is called ammonia regeneration tower. This tower we can call it as ammonia regeneration tower. Sir, ammonia is regenerated. That ammonia we are taking here. Bicarbonate decomposes, that gives carbon dioxide, that carbon dioxide also passed here. Okay. So carbon dioxide will be little will be there. Ammonia will be more. Why carbon dioxide is little? We are passing carbon dioxide here. No? That carbon dioxide is utilized for converting sodium ions into sodium bicarbonate. The remaining carbon dioxide only comes like this. Therefore, here carbon dioxide is little, but ammonia is excess. Okay. Now, this ammonia, the produced ammonia and produced carbon dioxide is recycled, taken into first tower again. Here calcium ions produced, the calcium ions will be drained out. The calcium ions will be drained out like this. Calcium ions, chloride ions and all will come out like this. Here chloride ion is there, means that chloride ion is taken into this tower, that will draining out. So we can say that calcium chloride goes out, we can say. This method is called Solvay process, otherwise ammonia soda process. In this method we are manufacturing what? In the sense sodium carbonate. Even this brine solution contains potassium ions. That potassium ions will come to this filtrate, that will come to here, that will become potassium bicarbonate, but potassium bicarbonate solubility is very less. Sorry, so potassium bicarbonate solubility is more than sodium bicarbonate. Therefore potassium bicarbonate will not come to this residue. Therefore we cannot prepare potassium carbonate by this method. Okay, so now this brine solution contains sodium ions as well as potassium ions. That sodium ions we are converting into sodium carbonate. Can we convert potassium ions into potassium carbonate? No. Why we cannot convert potassium ions into potassium carbonate? Because potassium bicarbonate solubility is more when compared to sodium bicarbonate. So potassium bicarbonate is not precipitated here. Therefore we are unable to get potassium carbonate in this method. So next we will see properties of sodium carbonate. Have you seen sodium carbonate anywhere? Sorry. Now we will take washing soda. The washing soda contains mainly sodium carbonate. The washing soda contains mainly sodium carbonate. That formula is Na2CO3.NH2. It is washing soda. You might have heard that washing soda, whenever we are using we have to use it immediately. We have to close that and we have to keep. we should not expose the washing soda into the atmospheric air. Why we should not expose the washing soda into atmospheric air? Because this washing soda is a efflorescent salt. It is a efflorescent salt. This washing soda is a efflorescent salt. What is meant by efflorescent salt? Efflorescent means the hydrated water molecules will evaporate away on exposure to air. Therefore, we should not expose this to atmospheric air. As soon as we have used, we have to close this one. We have to close this one. Air should not be in contact with this. Like this, we have to keep. Sir, this washing soda on heating with the air, on heating, what happens? This on heating, what happens means it loses water molecules. It loses water molecules. Like this, it becomes. Then it is heating to 373 Kelvin. It is heating to 373 Kelvin, becomes what means Na2CO3.H2. On heating to greater than 373 Kelvin, on heating to greater than 373 Kelvin, it becomes a soda ash. It becomes what in the sense? Soda ash. It becomes soda ash. This soda ash is not decomposing even on further heating. The temperature will reach the melting point. At the melting point, it will melt, it will not decompose. Sodium carbonate is like this. So alkali metal carbonates except lithium carbonate do not decompose easily. They do not decompose even at their melting point. Then this soda ash melts at 852 degrees Celsius. Okay. Then we will see uses of sodium carbonate. Sodium carbonate is used for water softening. If we add sodium carbonate into water, what happens means the hardness causing calcium ions, magnesium ions will be precipitated. Therefore, we are using this sodium carbonate for converting hard water into soft water. Then it is washing soda, therefore it will be used for cleaning clothes. Then it is used for the manufacture of glass, soap, borax. Borax formula is Na2B4O7.10H2O. It is borax used for preparing borax. Then caustic soda, sodium hydroxide, used for preparing sodium hydroxide. Used in paper, paints and textile industries. In paper industry, textile industry, then paint industry, it is used. In the laboratory, it is used as a reagent for qualitative analysis as well as for quantitative analysis. Then we will go for sodium bicarbonate. Sodium bicarbonate is used in fire extinguisher. It is antiseptic. Sodium bicarbonate is a mild antiseptic for skin infections. Then we will see uses of alkali metals. Uses of alkali metals, first one we will take white metal. We are taking white metal. This white metal contains lithium and lead. Lithium and lead. It is used for preparing bearings for motor engines. Then lithium plus aluminum. Lithium plus aluminum is used for preparing aircraft parts. Aircraft parts. Then lithium plus magnesium. Lithium plus magnesium is used for armor plates. Armor plates. Lithium is used in electrochemical cell. You can see that lithium batteries you can see. So lithium is used in electrochemical cell, that means batteries. Then sodium plus lead alloy. Sodium plus lead is used for preparing PbEt 4 times tetraethyl lead and tetramethyl lead. Liquid sodium. Now we are taking liquid sodium, that means molten sodium. is used as a coolant for fast breeder nuclear reactors. Fast breeder nuclear reactors. That means it is used in nuclear reactors. Nuclear reactor means converting nuclear energy into electrical energy. Then potassium chloride is used as fertilizer. Then potassium hydroxide is used for manufacturing soft soap. Potassium and cesium is used as electrodes in photoelectric cells. In photoelectric cells, potassium and cesium are used as electrodes.